Hello students, welcome back. This is the thermodynamic part 2. I'm Dr. Maya Dunne. In this part, we are focusing on calorimetry, specific heat and specific heat capacity. Calorimeter is the equipment to measure the heat changes. And then how do we measure the heat changes? By looking at measuring the temperature change and then applying that to an equation. The specific heat is the heat of a substance is the amount of heat required to raise the temperature of 1 gram of a substance by 1 Celsius. So heat capacity is amount of heat required to raise the temperature of an object by 1 Celsius. Heat capacity of 1 kilogram of water is you need increase the 1 gram of water in 1 Celsius, you need 4.184 joules. So this is like 1 kilogram because it's 100 grams. If you need one gram, it's 4.184. 1 kilogram, 1000 grams, you multiply by 1000. Specific heat and heat capacity. So the specific heat you can calculate Sm delta T. So M is the mass, S is the specific heat, delta T is the change in the temperature. So I have a question. Calculate the amount of heat required to heat 1.01 kilogram of water from 0.5 to 30, 5.81. So you get the mass, you convert it to grams because always it's given in the grams, and you might use the heat capacity and the temperature change. And then you get this number and then you convert joules to kilojoules. I have another question. Calculate the amount of heat in kilojoules required to heat 225 grams of water from 25. So Q equals M S delta T. M is mass. And then S is specific heat capacity. It's given here 4.184. Delta T, temperature change. Final temperature 90.5 minus 25.2. You get 65.3. And you multiply all these three together and then you get the heat. But it's given in joules. So you divide by joules to kilojoules, divide by 1000, you get kilojoules. If you do the reaction in the atmospheric pressure, it is constant pressure calorimetry. And then the constant pressure calorimetry, always the system is the water, the liquid in the calorimeter, that is the system. Everything else is the surrounding. The system is negative, releases heat, but the surrounding should absorb the heat. And I have a question here. A metal pellet with mass of 100 grams, originally at 88.4, dropped into 120 grams of water, originally at 25. The final temperature of both pellet and water is 31. Calculate the heat capacity. So here, I wanted to let you know how do you do it because it's kind of so here, heat always transferred from the higher temperature to lower temperature. The metal pellet with 88.4 drop into the water, it slowly loses its heat. So here the metal pellet is the system. Water is the surrounding. Metal pellet loses its heat, but water absorbs heat. So if I write the equation, metal pellet, we have to find this. So it's going to be like this. Q system negative equals positive Q surrounding. Our system is metal pellet. So I'm writing the temperature change. So it is going to be mass of a metal pellet, which is 100. And then C I don't know. That's what I'm looking. Delta T is 88 to 31 because 88 is the final temperature. 88 minus 31. I getting so the palette always you have to find the delta, right? So it's delta T final minus initial. So the final temperature would be 31.3. Initial would be 25.1. So I'm getting my answer as negative 57.1, right? No, initial E is not, sorry, not 25. Initial E is 88.4. 88.4. So I get the difference, so that goes here. Negative 57.1 equals, you write water, mass of a water, what is the mass of a water? 125. You know the heat capacity of water, which is, that's a constant. You don't have to memorize. I'm going to give you in the exam. 4.184 joules Celsius, joules per gram per Celsius. And then temperature change, which is, at the beginning you have 25. Final is 31. So 30 here you see 31.3 minus 25.1, 6.2. So that temperature 6.2 comes here. And then you multiply all these things and you multiply 5700 equals, so by dividing these two number, this whole number by these two numbers, I mean, you multiply this and then you multiply 57.100 and then you divide this number. So let me go to the next page and I show you in detail. You have some idea before we go to the next page what are the numbers we are looking for. Here you see Q water mass, C is specific heat capacity, temperature change, and then Q pellet you get so that equals to the Q, but you know C is they don't ask the specific heat capacity, they ask the heat capacity. So heat capacity is the combination of, you see, Q C delta MS delta T, sorry, MS delta T, and then heat. So this is we call S is specific heat capacity, but in this case here, it's C is both MS combined, we call C heat capacity. So you just get this term from this side and then multiply. So you have this whole number equals to the heat released from the heat, the pellet. So that's why you equal to this one, and then the you divide 3,242 by 57 and you get this number. Let me double check it. Yeah, that's correct. That is how you do this kind of a question. And we have the constant volume calorimetry. We call the bomb calorimetry. It is no temperature, no volume change. It's in the small that container. So there are different types of calorimetry. And then we go to the standard enthalpies of formation, delta F. If you have to find the energy change for a particular reaction, you find the enthalpy of the products, and then you find the enthalpy of the reactants. Products minus reactant is the enthalpy of a reaction. That's what I'm showing here. A, B, B, C, A, B are reactants, C, D are products. So get the enthalpy of the products and multiply by the number of moles present, add all the products, and then subtract by the reactants. So the bond enthalpy, so it's total, so the bonds always, the bonds broken, minus bonds formed, it's another word, it's products minus reactants. So these are some bond enthalpies. So you can just see when you have the double bond is more stronger than the single bond. So those kind of things you can have some idea. And I think that's about the chapter 10. And I hope this video helpful for you to understand the concepts in chapter 10. Thank you.